Welcome to Let's Talk Micro. Hello, dear listeners. Welcome to another episode of Let's Talk Micro. As always, I hope you had a great week. And you can always find Let's Talk Micro on Apple Podcasts, Spotify, Amazon Music, Goodpods. Wherever you listen to podcasts, you can find Let's Talk Micro. As far as social media, I am on Instagram, TikTok, and YouTube as Let's Talk Micro, on X as Let's Talk Micro 1, on LinkedIn as Luis Plaza, and I have an email address which is letstalkmicro@outlook.com. So either via social media or email, you can leave any feedback, any topic suggestions. Those are always welcome and appreciated. So please go ahead and subscribe to the podcast, download episodes, and if the app allows you to do so, please go ahead and leave a review. Thank you so much for the support. As you know, Let's Talk Micro has many episodes to choose from, over 100 actually, all the way from organisms, reactions to antimicrobials. So either, you can download one or just download them all. But as I said before, I am so grateful for the support. And speaking about antimicrobials, if you are looking to learn more about antibiotics, please check out www.learnantibiotics.com. And also the Learn Antibiotics book available on Amazon. These resources include cheat sheets, practice tests, games, and more, and they are being used by thousands of people worldwide and may be helpful for you or your colleagues. So definitely check out these great resources from Dr. Timothy Gauthier. So if you haven't listened to the previous episode, please go ahead and do so. It was about Listeria, so the past episode was not an interview. It was an episode where I sat down and I started talking about an organism, breaking it down, talking about media, biochemicals, diseases. So if you haven't checked it out, please go ahead and do so. So before we move on to today's episode, let's go ahead and do a quick recap about the previous episode. So Listeria is a gram-positive rod, catalase positive. It is beta-hemolytic. The most significant species is Listeria monocytogenes. There are other species, including one that I'll be talking about later on, and there are some that are sensu lato, which means in the broader sense, and they might be reclassified at a later time. One of the concerns with Listeria is that it is able to survive at cold temperatures, like about 4 degrees Celsius, and we can acquire it from eating contaminated food products that we keep at those temperatures, like cheese, processed meat, and cold cuts. I mentioned an interesting fact from the Manual of Clinical Microbiology from the ASM, and that is that our intestinal tracts are colonized from 1 to 5% with Listeria. So, Listeria is seen in food-related infections, and this is how it's primarily transmitted. And you also see outbreaks in neonatal wards. In adults, it is seen in septicemia, meningitis, gastroenteritis, and central nervous system infections. I also went over virulence factors, such as Listeria lysine O, which enables Listeria to avoid intracellular killing. And as I mentioned, this is a very significant organism in newborns. So you lab techs, we medical lab scientists, when we are working blood cultures and we see short gram-positive rods, we need to rule out this organism. So we need to be thinking that on a newborn. And I'm going to be talking about some methods of identifying it, but just to make sure, this is something that we have to keep in mind. And I mentioned in the previous episode that there are also some atypical presentations. Those of you that work in the lab in microbiology, you're familiar with the fact that using a description for the morphology of gram-positive rods, that's a big part of when you are looking at gram stains. And for gram-positive rods, we use terms like boxy for bacillus, thin and long for lactobacillus. We describe spores. We use terms like coroniform for Corynebacterium. And with Listeria, the rods are short. So when you're seeing those and your patient is a newborn, you need to be thinking about Listeria. But as I mentioned, you can have atypical presentations, which means sometimes you get an adult patient and you get a positive blood culture, like about 24 hours, and you see gram-positive rods that they don't have that typical short morphology. But then when you do a blood culture ID, Listeria comes up. And then when you plate it and the next day you look at it in the media, Then you see the typical morphology, the typical gram stain. So this is something to keep in mind, because a lot of times in blood cultures, gram-positive rods tend to be a sign of contamination. Like you see Corynebacterium, you see Bacillus. To a lesser extent, you can see Lactobacillus. And this is something that maybe it flags as positive about 3 days in. And as I mentioned, blood cultures are kept for 5 days for bacteria. And then if they are negative after 5 days, they are discarded and the culture is finalized as no growth 5 days. So in the case of this atypical presentation, you get a positive blood culture at 24 hours, and then the gram stain is not the typical morphology, but then once it's been plated, the next day it will have that typical morphology. So this is good for you techs out there to have that in the back of your mind. Well, today's episode is about media that is used to identify Listeria. And before I do that, I'm going to talk about two systems that use some tests to identify it from blood and cerebrospinal fluid. As you know, this is a critical organism, and you see it in meningitis, and you see it in septicemia. So there are molecular tests that are used to identify it from these particular sample types before you even put it on agar. And the two systems that I'm going to talk about, the tests, are the BioFire system from bioMérieux, and then I'm also going to talk about the GenMark ePlex from Roche. And I have touched on this before on previous episodes of the podcast, but a refresher is good. Okay, so let's go ahead and start talking about the BioFire system. So it has the BCID2 panel, which identifies Listeria from blood cultures, so from blood. And then it also has the film array meningitis encephalitis panel, which identifies Listeria on cerebrospinal fluid. And some of you in the audience, you might be familiar with one test or the other. I mean, I know years ago I used to work with the BCID from the BioFire, but that was before they came up with the BCID2, which in addition to Listeria, it identifies other gram-positive, other gram-negatives, it identifies some yeast as well, and all in one test. So that's actually really good, and that's one of the pros of this test, that you run one test and it can detect all these targets. So definitely very convenient, and it takes about 1 hour for both tests. So this is a very simple setup, and there is a test pouch, a sample injection vial, a hydration vial, and buffer. And the vials, they're injection-like, which means that you kind of push them and inject them into the test. And when you do that, you hear like a pop sound. And then they are color-coded, blue for the hydration vial and red for the sample vial. Very simple. You inject the hydration vial in the appropriate area. Then, to the sample area, you're going to add the buffer and an aliquot of blood or CSF, which is 200 microliters. Then you go ahead and mix the buffer and sample mixture and inject them in the appropriate area of the test. And like I said before, you hear a pop when that happens. And this is not a promotion of any kind. I mean, I am talking from experience that I work with the BioFire system, and it is a good system. And of course, when I was working with it, the BCI2 panel, it wasn't there yet. I mean, I think it was in the process of being made and coming out. But the BCI2 panel, in addition to the things that I mentioned, which were it can detect, gram-negative, gram-positive, yeast, it can also detect resistant markers such as VAN-A, MEK-A, and resistant markers for carbapenem resistance. So I think overall it is a really good test. And as I said, it takes about an hour. And then the meningitis encephalitis panel, in addition to Listeria, and I just want to emphasize that both the BCID2 and the meningitis encephalitis panel, they detect Listeria monocytogenes. Just want to make sure that you all know that. And in addition to that, the meningitis encephalitis panel, it also has some targets for viruses and other bacteria that are seen in meningitis, such as E. coli, Haemophilus influenza, Neisseria meningitidis, Streptococcus pneumoniae, Streptococcus agalactiae, and Cryptococcus. So it's a very complete test. So Both tests, the setup is the same: hydration vial, buffer, sample vial, and then you aliquot 200 microliters of either cerebrospinal fluid or blood, depending on the sample type and test that you are performing. So then, definitely a great test. And then the other one that I was going to talk about is the GenMark ePlex, which is now part of Roche. And for this one, actually, the setup is even easier. Whereas in the BioFire, there was a test pouch, here there's a test cartridge. And all you do is you add 50 microliters of your sample, which is blood, and then you add that to the test cartridge and you place it in the instrument, and the result takes about 90 minutes. This one detects Listeria and Listeria monocytogenes. And you can do actually a whole episode talking about both systems, limitations and more components. So this is pretty much all I'm going to mention about them. That one detects Listeria monocytogenes, which is the BioFire, and then the ePlex detects Listeria and Listeria monocytogenes. Now, I will say that perhaps a drawback of the ePlex is that you need a test cartridge for gram-positive, one for gram-negative, and one for fungi. So you will have to do your gram stain first, and then once you know what you have, go ahead and pick your cartridge. Which with the BioFire, as you're doing the gram stain, you can set up the test. So maybe it's a little bit easier. And then when it comes to the BioFire, I will say the only drawback is like each test, and this is when I was doing it, and I think that this is still the case, that each test came in a little like an aluminum cylinder, and those pile up really quick, and you have to take them to recycling. So as of right now, maybe that's the only drawback. But I'm not going to say anything else about these systems. As I said, there's a lot of information, and you can, like any system, there are some limitations and some things that can happen. But overall, those are two tests that you can do to detect Listeria. Okay, so let's go ahead and talk about media. So as you know, it grows well, Listeria grows well on blood and chocolate. And also, like early in the podcast, I mentioned other media. And today I'm going to repeat some of them. So let's go ahead and talk about it. So when we talk about blood samples, those can be plated in traditional media, like blood, chocolate. And then when you have other type of samples, such as food samples or non-sterile samples, you can use the agar that I'll be talking about. So the three different types of agar that I'll be talking about, they're mainly used for food samples. And it is recommended for food and environmental samples that prior to inoculation into media, that the samples be placed into an enrichment broth. And information about enrichment broth and Listeria agar can be found in the Food and Drug Administration webpage, the FDA. So for example, there's a broth, an enrichment broth, called the Buffer Listeria Enrichment Broth, and it has trypticase, soy broth, and yeast extract, among other things. It also contains agriflavin HCl, nalidixic acid, and sodium hexamide. And then once the samples have been placed in this enrichment broth and incubated, then you can go ahead and proceed to inoculate it into the media that I'm going to be talking about. So let's talk about the first one, and it is Palcalm agar. And I got this information from the Sigma Aldrich website. So it was developed for the isolation of Listeria monocytogenes from food items. And Palcalm is an abbreviation for polymyxin, agriflavin, lithium chloride, ceftazidime, esculin, mannitol. So in order to achieve isolation, the agar has lithium chloride, polymyxin bisulfate, agriflavin HCl, and ceftazidime. This agar is selective and differential. The differential portion is for esculin hydrolysis, which all Listeria species do hydrolyze esculin. So once the esculin is hydrolyzed, it reacts with ferric citrate, producing a brown-black color in the agar. Sometimes you can get staph and enterococcus growing in the agar, and for this, mannitol has been added. And an organism that ferments mannitol, which Listeria does not, the colonies are seen as a red to yellow color. So in this agar, Listeria looks as gray-green colonies surrounded by dark brown to black halos after 48-hour incubation under microaerophilic conditions. Another type of agar is Oxford, and this one is also intended for the selection of Listeria monocytogenes from food items, and it is actually recommended by the FDA for this purpose after being placed in enrichment broth, of course. And one example from Oxford is from Fisher Scientific. So this agar has Columbia agar base. It contains lithium chloride, fosfomycin, colistin, cyclohexamide, and this is to inhibit the growth of both gram-negative and gram-positive bacteria. Just like Palcalm, the agar has esculin, which is hydrolyzed by Listeria. And Listeria monocytogenes colonies are black with a black halo and a sunken center. And this is after 48 hours incubation at 33 to 37 degrees at aerobic conditions. And I definitely think, it is good to talk about this and learn about this because sometimes, us as medical laboratory scientists and those of you in the audience that maybe work in clinical microbiology, as you know, when we get Listeria, it's pretty much from a blood culture or maybe a CSF. But most of the times that I've seen it, it's from blood cultures. So for those, we typically have the regular media that we use in the lab, like blood and chocolate. So we don't have this type of media. Now, if you work in environmental microbiology or you work with food, then you're definitely more than likely familiar with this media. I mean, I know I had the opportunity to talk to Carla Zamora, which she's a microbiologist from Mexico. And she works in food microbiology, and she's definitely familiar with the agar. So if you're listening and you work, dealing with microbiology for food items, you might be familiar with it. But those of you that are in clinical micro might not. And of course, there's also some chromogenic agar. And I have talked about chromogenic agar before, and just a quick summary. So this type of agar, it typically has a component in the media that if the organism has like an enzyme that breaks down this component, the colonies produce a color. And that's how you're able to tell, and you have agar for like MRSA, methicillin-resistant Staphylococcus aureus. You have agar, chromogenic agar for VRE, vancomycin-resistant Enterococcus. There is also chromogenic agar for Enterobacterales. So this is not an exception. So there are different manufacturers out there, and they are mostly ALOA based. The agar is ALOA based. And ALOA is Listeria agar, according to Ottaviani and Agosti. And they are the ones that designed the formulation for this agar. So I was checking online and I saw the BioRad website. They're a company that designed many diagnostic products. And according to their website, ALOA is based on the simultaneous detection of beta-glucosidase and, bear with me here, phosphatidylinositol, a specific phospholipase C, which is abbreviated as PI-PLC. Well, the beta-glucosidase activity is detected using a chromogenic substrate, which is X-glucoside. When this substrate is hydrolyzed, Listeria colonies produce a blue to green pigment. And then the PI-PLC is only detected in Listeria monocytogenes and Ivanovii. This agar has phosphatidylinositol, which once is broken down, an opaque halo is produced in these colonies. And for Listeria monocytogenes, this is seen at 24 hours, and for Ivanovii at 48 hours. And there is a version of this from Hardy Diagnostics, where the agar, the colonies, they are turquoise with a white halo. So, okay, let's go ahead and do a quick recap because it is a lot of information. So, as you know, Listeria, gram-positive run, catalase positive, it is seen in meningitis and septicemia. So today we talked about two tests that are used for the detection of Listeria in blood and cerebrospinal fluid. So there is the BioFire system, which has a meningitis panel and a blood culture panel. Setup is the same. Very simple. There is a sample injection vial, there is a hydration vial, and a buffer. And then you go through the steps. You add your hydration vial, and then in the sample injection vial you add buffer, and then 200 microliters of your sample. If you're doing meningitis, you're adding cerebrospinal fluid. If you're doing blood, you're adding an aliquot from your blood culture. And then the test, they take about 1 hour. So, and then there's also the ePlex panel from Genmark, from Roche, that you use it for the detection of Listeria and Listeria monocytogenes, because I emphasize that for the BioFire, it is Listeria monocytogenes. So with the ePlex, you have a cartridge for where you put 50 microliters of blood, and the drawback is that you have to pick one for gram positive, one for gram negative, and one for fungi, depending on what you see in the gram stain. Whereas with the BioFire, you have all these targets in one test. And these tests, they definitely make sense because you do see Listeria in septicemia and meningitis. And then you find Listeria in foods. It likes things like, it can survive in things like cheese and cold cuts and other things. So you see different outbreaks. So definitely you have media that is used for the detection of Listeria in food samples. And that's what we talked about today. We talk about 2 types of agar that are based on esculin hydrolysis, which are Palcalm and Oxford, and then one that is chromogenic, and which is based on the activity of 2 enzymes, one being PIPLC and then the other one beta-glucosidase. And if you work in clinical microbiology, you might not use this type of agar because, we normally just, when it comes to blood and CSF, we use blood and chocolate. So maybe this, but it's good. It's always good to learn. But definitely, if you work in food microbiology, you might be familiar with it. But definitely, the take-home message is that this is a very serious organism. And if you start seeing a presentation where you have a newborn, you see short gram-positive rods, definitely start thinking Listeria. Keep in mind that you can have some atypical presentations. And when the organism grows in the agar, it can resemble Streptococcus agalactiae. But of course, you do a catalase, you do a gram stain, and you can differentiate both. And of course, you have other systems to identify it once it's been on the plate, like Vitek and Molotov. But once again, definitely a very critical organism, and one that is reportable to the state nationwide here in the United States. And you can find all this information in the Center for Disease Control and Prevention webpage, the CDC. And that, my dear audience, it's the end of this episode. As always, I hope you enjoy learning about Listeria, media, testing, and more. As always, I enjoy sharing this information with you. So please continue bringing that passion to what you do. It's so important. You do such great work. And as always, stay tuned. Thank you for your support. Please continue downloading episodes and sharing Let's Talk Micro with a friend, with a neighbor, with a team member, with your department. Just let people know that Let's Talk Micro, it's out there. I am so grateful for all the support. As always, stay motivated, stay safe, and of course, continue talking micro. Until the next time, bye.